Okay, Hamizah semua sihat soalan harap semua okey lah dalam good condition Okay, I share my screen dulu. Okay, we continue our class on protection Okay, power system protection boleh nampak Okay.
Nampak sir.
So this topic we have already discussed in I think last week Yes, last week. Okay. So we try to recap balik what we have discussed about protection, power system protection. Okay. So basically, protection is try to protect our equipment. Clean power system, we try to protect our network power system line. In the power system, we have equipment such as transformers, generator, bus. So we try to protect all the equipment. Okay. So in order to avoid from insulation damage, conductor melting, mechanical damage to winding and bus bar, fire and explosion. So these are the effect of not removing the faults. Okay, so we need to protect our system. All right, power system. Wait, there's someone entering my room. Okay, right. Power system have three basic components. Instrument transformers, relays, circuit breakers. So you nak faham tentang protection, you have to know, you have to understand about these three elements, components. You kena faham. When it comes to the instrument transformers, ni dia lah, we talk about current transformers and voltage transformers. Okay, what's the current transformers? What is the voltage transformers? I just explain kat you. Okay, basically it try to sense the for the current transformer, it try to sense the current, then it turn the ratio, turn the from primary to secondary current. Okay. So similarly for concept for voltage transformer sama juga, it sense the voltage, fault voltage, this one current, fault current, then it minimize the fault voltage. Ini current, sama Relays, we have these are the type of relays, overcurrent relays. Okay, nama for overcurrent so it sense the overcurrent. We have directional relays. Okay. Directional relay ni, if you still remember, it's operate based on the direction, nama direction forward direction. Okay, then we study about the impedance relay. Ini belum belum. So today we are going to cover on impedance relay and differential relay. So we have 1, 2, 3, 4 type of relay which are being used in the practical power system protection system. Okay. System protection components, okay, I nak refresh balik apa yang you faham. Okay, nak recall balik. Alright, so we basically, let's say this is the transmission line. So in the transmission line, we locate our current transformer. CT is the current transformer. Alright, so current transformer, let's say we are using overcurrent relay. So it will be connected to the coil of overcurrent relay. Whenever the coil is energized, because of this secondary current, I prime, contact will turn on. Bila contact turn on, what happen is, kat sini ada battery, so the current will turn on energize the breaker trip. Breaker coil akan turn on. What happen, connector dia akan turn on lah, dia akan close, open. So kalau close tak boleh, kena open. Kalau dalam normal condition, dia close because current is allowed to flow from this area to this area. However, whenever there are faults, breaker ni akan open in order to isolate the faulty, the fault current from going to this area. For example, this is our protection area. Okay, so this is the basic operation of current transformer and overcurrent relay. Okay, semua faham tak konsep operating of relay ni? Kalau tak faham relay, you tak faham juga cerita. Faham tak konsep relay macam mana operating? Mungkin ada faham, mungkin tak faham kan? So tak apa apa benda ni tak apa. Okay. Okay, I nak beritahu you, kalau siapa yang pernah deal ataupun working with relay, I try to Google relay mana. Apa ni relay? Siapa tengok relay ni? Siapa pernah pergi kilang ke? Pernah beli ke? Pernah guna?
Pernah sir.
Mungkin sama you tahu kan?
Pernah dulu.
So, okay, ini relay lah. Banyak jenis relay kan. There are so many type of relays, tapi basically konsep dia sama operation dia. So basically relay ni dia akan ada, it has what we call macam ni lah, coil lah, macam ni ada lah. Okay, ni simple structure for a relay. So relay biasanya dia akan ada normally open dengan normally close. Kalau normally close ni dia always close. Normally open ni dia always open. So bila coil ni on, dia ini akan jadi close. So current maksudnya circuit dia akan close lah. So current boleh flow. So ini yang biasa kita guna untuk overcurrent relay where it always normally open. Ada juga this relay where the contact is always closed. Whenever the coil turn on, dia akan jadi open. Dia akan inilah breaker. Breaker ni macam ni konsep dia. So dalam normal operation without fault, dia always close. Bila coil dia turn on, dia akan open. So dia akan open the circuit. Bila dia circuit, current tak boleh flow, so dia akan isolate the fault current ya. Okay. Itu breaker. But for the overcurrent relay, bila coil turn on, maksudnya bila ada fault current, dia akan sense the fault current from the CT, current transformer. Dia akan onkan this coil, kan this one akan close. Itu konsep dia. Kalau you back to the note kat sini lah. So this lah konsep. You kena faham lah konsep of relay. Okay. So dia contact pada coil. So maksudnya whenever I prime ni is greater than pickup, and kalau overcurrent relay ni dia ada pickup current nama dia. Whatever this I secondary current of current transformer ni is greater than the pickup current, so dia akan energize, dia akan turn on the coil. So when they turn on the coil, contact dia akan close. Bila close, so dia akan onkan this breaker coil, dan breaker coil akan open. So this is normally open and this is normally close. Itu konsep ni. Okay, faham So this one I takkan cerita because I dah explain pada you all, cuma I nak you ingat balik dah. Right? So system protection component, instrument transformer. So we have current transformer, voltage transformer. Konsep sama juga untuk voltage transformer. Cuma current transformer basically we connect in this way lah, dalam bentuk macam ni Okay, series Kalau voltage dalam bentuk parallel. Okay. Relay. Okay. Instrument transformer ni current transformer or whatever. It's step down the current or voltage. Betul lah. This the sense and step down for the measurement. Yalah, kalau during the fault current is very high, it can be 1000 amps, kilo amps. So it need to be step down to the lower value of currents untuk measurement. So 5 amp, biasanya less than 5 amp. So this is the function of current transformer. Voltage transformer sama juga, it step down the voltage. Then the relay, next is goes to relay. Receive the current transformer or voltage, receive the currents or voltage from the CT and VT. Okay, identify whether fault happens. If yes, it tells the circuit breaker to open. Jadi, circuit breaker, it contact remain closed if no fault happens. When the fault happens, its contact open and separate the faulted zone from the remaining system. So these are the flow of system protection component. You tak kisahlah you pakai what kind of relay, konsep dia sama. You pakai overcurrent relay, you use the directional relay, you use the differential relay, konsep dia sama. The flow sama. Okay. Right. Okay. Alright. So next we go to this one. Instrument one, I dah explain. Right. Okay, tak nak explain semua, nanti masa tak cukup. So you boleh go through by yourself. Baca dululah. Kat rumah tu you baca, you study protection. Tak susah pun, very interesting. Ada orang buat research on the protection. Okay. Alright. Okay, this one overcurrent relay. So I dah cerita. So in order to operate the overcurrent relay, the secondary current for the CT must be greater than pickup current. Pickup current must be minimum. Minimum coil tu nak on. Okay, berapa amp? Contohnya coil tu turn on dia kena 4 amp contohnya. So I prime, this current must be greater than 4 amps. Kalau tak, coil takkan on. Contoh macam itulah. So this is the condition. Okay. If I prime less than IP, the relay contact remain open, blocking the trip coils. So this is the kata diagram to show the operation region for overcurrent. Kalau you tengok block ni, apa maksud dia? So this is the trip region. Maksudnya kalau whenever I secondary, I prime tadi greater than IP, the pickup current, so kat sini dia akan trip. Whenever the I prime less than IP, dia akan berada di block region. So relay tak trip. Overcurrent relay not okay, dia tak akan operate lah because of the I pickup dia greater than the I prime. Secondary relay current. Kat mana sebenarnya saya secondary kalau you tak, mungkin tak nak capture. Contoh kita back to the circuit kat sini. Dan inilah current ni. Okay. So current ni must be greater than the pickup current yang saya sebut tadi lah. So this is the diagram to show the region of operating for overcurrent relay. Okay. Then next one we have time delay. Time delay ni maksudnya sometimes we don't want to the relay operate instantaneously. Tak nak kita terus operate. We put a time delay. Mungkin 0.5 second, 1 second. Dia ada time delay. So this is overcurrent relay with the time delay. So we can see from here TD3, TD1 ini paling cepat biasanya in term of time lah. Maksudnya yang paling cepat this one lah. Paling okay. Alright. Then you have this curve. Okay, then we are using the overcurrent relay to protect the single line diagram. Okay. Kat sini ada cerita tentang backup protection. If this breaker ni tak open, this one akan backup. So boleh baca, go through, tengok sini nanti. Okay, this one I dah explain. Okay, then we go to the directional relay. So what is the directional relay? Look at the name pun kita faham. This is it operating based on the direction. Ataupun kita katakan it will operate on the forward direction only. Kalau dia reverse direction, dia tak akan operate. Itu sangat penting sebab kita sometimes when we try to do the protection, we can imagine the bus system is very complicated and complex, so kita kena ada directional. Tak boleh semua sekali. Kalau trip kat sini, kalau fault this bus, semua trip. Tak boleh because it will disturb other operation. We try not to disturb other people operation, so we need put just the fault area only. Breaker masuk on untuk fault area. Okay. Alright, overcurrent relays. Then there's a combination between directional relays and overcurrent relay. Okay. Kat sini pun you boleh nampak kat sini. So satu D is the directional relay, OC is the overcurrent relay. So the combination. Satu dia nak based on the fault current. Okay. The magnitude of fault current, the other one is the direction. So they combine. Okay. Alright. So this is the block region. Satu dia block kat atas. Satu dia trip region. Maksudnya kat sini directional relay will trip whenever the fault current ataupun I prime ni, secondary CT current ni lies berada in this region sebab dia directional. Kalau kat sini dia tak akan operate so that this is the meaning of the directional. Okay, so ada some equation kat sini. Okay, kat sini dia cerita sikit the lag and lead tapi yang you faham konsep dia juga tengok kat sini lah okay, kat sini boleh nampak kalau in this diagram dia tunjukkan contoh B12 dia operate in this direction B32 in this direction, B21 you tengok kan ni arrow kat sini, so dia ke sini ke sini kan. Okay, ini ke sini, right? Okay, ini ke sini. So dia akan determine the which is the forward and which is the reverse direction. So I dah space dulu sebelum ni, I think you masih ingat lagi I hope you faham Okay. Alright. Then the next one is about the zone of protection. Ini pun simple because in the system network, bus network, We have many numbers of bus. Banyak bus Bukan satu kena dia, mungkin more than 10. Kalau ikutkan sistem, tengok area. If the urban area ataupun kawasan-kawasan yang many people, so what happen is, of course lah, bus dia sistem lagi complicated. So we need to do some kind of zone of protection. For this example, dia ada 3-4 zone, berapa zone, banyak zone. So the zone protection ni, apa yang you belajar sebelum ni is about the overlapping zone. Whenever the overlapping zone, kalau berlaku contohnya kat sini, fault at P1, which is P1 kat sini. So mana zone yang overlap, dia akan breaker dia akan open dia akan clear the fault. Okay. So you boleh baca lah. Contoh kalau fault at P1, breaker 24 and B42. 24 and B42 kat sini. Okay, so for kat sini, both breaker dia akan open in order to isolate the fault. Okay. However, when P2 which area? P2 mana dia P2 kat sini? This one. So P2 ni dia is orang kata located in the overlapping zone. So semua breaker yang berada dalam zone ni dia akan trip, dia akan open lah. Okay, contact in order to isolate the fault. Okay. Alright. So today we are going to discuss about impedance relay. What is that? Nama pun impedance. Sometimes protection relay ni dia based on the orang kata characteristic of the relay. Kalau impedance, you can imagine it's about the impedance, the Z. Okay. Alright. Sampai sini okay ke semua? Okay kan? Semua dah ada. So we have about 28. Okay, very good. 28. Okay, 28. Alright, commonly used to protect buses and transmission line. So commonly we use bus and transmission line impedance relay. Okay, this relay operate based on voltage to current ratio, which in turn produce impedance. Okay, kalau you back to the Ohm's law V sama dengan IR, V equivalent to I times R kan. So actually R the Z lah impedance. So Z is the V over I. So based on the voltage over current ratio. Okay, dia akan produce impedance. Kenapa macam tu? Because during fault happen. Contoh kita kata fault okay, salah single line ke double line, ground to double line to ground. So cerita ni current dia akan increase lah, dia akan rise up very hard. So the ratio of V over I dia akan berubah, betul kan? Impedance dia pun berubah lah, betul. So itulah konsep of impedance relay. Dia akan sense the current. Alright. Okay. It also called a distance relay because the impedance is proportional to the distance in the transmission line. So boleh juga because the proportional to the distance. When we say about the distance, kita tahu transmission line ni dia ada distance, dia ada jarak berapa km, right? How many km? So based on the length of the transmission line. The reach of impedance relay denotes how far down the line the relay detect faults. The reach, ZR, Z reach. Berapa jauh the relay can detect the fault. For example, at 80% reach mean that the relay will detect any solid three-phase fault between the relay and 80% of line length. Maksudnya kalau from the 100%, 100% relay akan detect about 80%. Contoh macam itulah. Okay. Okay, sekejap and open something. Okay, not this one. Mana ni? Okay, stop presenting sekejap Okay, sekejap. Right. Okay. Okay, sampai situ any question nak tanya? Sebelum kita start pada impedance relay Okay, semua
Setakat ni okey Zat.
are you with me ataupun ada yang petang kan you ada kelas kan macam ni lah kan. Okay, tak apa. I tengah open something je. Okay, share screen. Alright. So, cerita dia gini lah. You ada satu transmission line So, dalam in this explanation slide ni kata example 80% reach mean that the relay will detect any solid three-phase fault between the relay and 80% of the line. For example, this is transmission line bus 1 to bus 2. Okay. So, we put relay kat sini lah. Relay kat sini. So, 80% from the line 80%. Okay, mungkin 80% Okay, dalam range ni. So, kat sini ialah balance is 20%. So, dia cuma detect about 80%. Okay. So, itu maksud dia So, I nak you clear pasal 80% kat sini. Okay. Impedance relay block and trip region are shown below. The relay trip for the impedance is less than the ZR. Z is the reach impedance. Tadilah reach impedance 80%. Okay. Where Z is the voltage to current ratio at the relay locations. Z are the adjustable relay setting. Tak salah, Z ratio kat sini. Means the Z is the what? Is during the fault. During fault ni, what is the value of Z? The Z must be there must be less than the ZR. Okay. Alright, itu maksudnya. So boleh dimension about reach impedance. Okay. So, ni ada the reach of impedance This is the ZR. Alright. The impedance fault Z must be within the circle. Dalam circle ni, baru dia akan trip. Kalau dia keluar outside the circle, means that the Z is greater than ZR, so dia tak akan trip. Relay tak akan turn on. Okay, itu maksud dia. Impedance relay. Right. Okay. Consider an impedance relay for breaker B12. So this is the B12 breaker, for which Z impedance to V1 over IL2. So this is this one. Kita consider this location fault kat sini. There is P1, P3, P2. Okay, zone 1, 2, 3 are the protective zone covered by breaker B12. Zone 1, zone 2, zone 3. Okay, sebenarnya impedance relay ni kita setting berapa dia punya impedance reach tadi? 80%, 120%. Okay, let I explain kat sini. Okay. During normal conditions, load current are usually much smaller than the fault currents, and the ratio Z VI has a larger magnitude. Okay, because Z because R is small, right? So Z is a large magnitude. Therefore, Z will lie outside the circle in block region, and the relay will not trip during the normal operation. So we back to this diagram. What happened during normal condition? The fault impedance is always greater than ZR. Because I dia tu orang kata small Okay. During three-phase fault P1, however, Z appear to rely B12 to be line impedance from relay. You tahu kalau fault ni I ni dia akan increase dia akan rise up So what happen, Z akan jadi small lah, become smaller. So basically dia akan located inside this circle. Okay. So alright, Z appear to relay B12 be the line impedance from the relay to the fault location. If Z is smaller than ZR in trip region, then the B12 will trade. So back to the second. Let's see if the Z is smaller than ZR, Z registered. So B12 akan it will trade. Okay. Alright. Also during three-phase fault, P3, Z appear to relay B12 to be negative of the line impedance from the relay to the fault. As long as Z is less than ZR in trip region, B12 relay will trip regardless of fault location, forward or reverse direction. Thus the impedance relay is not directional. So cerita kat sini, it try to mention that relay is not like directional relay, which is based on the direction. No, dia tak kisah as long dia dalam dia punya reach, dalam dia punya cover area. Okay. Yang mana? Contoh kat sini, P1 tadi kita back to this diagram. Okay. P1 Okay, P1 kat sini. So kalau ikutkan P1 still lagi dalam the protection zone of P12, so dia akan trade. So what happen kalau P3? Kalau dalam this slide dia mention Z appear to relay to be negative of the line impedance from relay to fault. Okay. So maksudnya kalau kita tengok pada konsep of forward and reverse direction can say that when the fault occur kat sini, so this one akan jadi reverse, dia jadi reverse direction. Tapi because the operator of it really not based on the forward or reverse direction, so if the trip kat sini, what happen is it will trip the B12 whenever B12 this fault located dalam the range, cover range of the B12 zone protection. Okay. So ini apa? Ini apa? Ini why zone ni kat sini, zone tu kat sini, zone 3 kat sini. This is later on I can explain. Alright. So this one basically this is 80%. Inilah 80%. Zone 1. Second zone dia ada penambahan 120%. And then zone 3 basically dia akan cari mana bus mana yang lagi longer lah between bus 24 and bus 23. Okay. Tak apa. Kita akan jumpa slide tu. Two ways to include directional capability with an impedance relay are, example, to make it operate in forward direction only, directional restraint by including a directional relay in series with an impedance relay. So same case with the overcurrent relay. Overcurrent relay they operate based on the current, magnitude of current. Okay, impedance relay dia operate based on the impedance, tapi dia tak ada directional. So in order to make it operating with the direction, so we need to combine with directional relay. Okay, so more relay by offsetting, dia ada dua benda kat sini. Okay, by including directional relay in series with an impedance relay, kita panggil directional restraint. And second is MHO relay and more relay by offsetting the center of impedance circle from the origin. Right. So these two basically they still impedance relay, but it has a direction because the orang kata combine, integrate with the directional relay. Okay. Alright. If either of this relay is used at B12 in the previous power system, a fault at P1 will result in trip decision, but the fault at P3 will result in block decision. Apa maksud dia kat sini kalau kita tengok betul kalau let's say B12 ni dia ada combination dengan directional relay. Satu dia pakai impedance relay, satu ni combine with the directional relay. So 3 at P1 basically dia akan jadi forward. Okay, nama forward because current akan flow ke sini kan. Tapi untuk case ni dia akan jadi reverse. Kenapa? Sebab kat sini current akan flow ke sini and current akan flow ke sini. So B12 ni dia tak berada. Kalau B13 dengan B31 tu yes forward direction, tapi B12 ni dia dah outside, dia dah luar pada flow of fault current tadi. So what happen, B12 become reverse direction. That's why dia tak akan trade. For this case, okay, dia cerita kat sini macam itulah maksud dia. Right? If either this relay is used at B12 in the previous system, for at P1 dia akan jadi trade decision. Kenapa? Because they are combination dengan direction relay. But a fault at P3 result in block decision. Dia tak akan trade because dia jadi reverse direction. Itu clear faham ya? Faham Itu maksud dia. So, you kan tahulah mana forward, mana reverse I cerita sebelum ni. Okay? Alright. So, kalau in case this relay combine dengan directional relay, without directional relay, dia akan kalau dia dah kat sini ni dia lukis because dia nak tunjukkan sebenarnya dia dalam region dalam region ni semua ni. Dia akan trip juga because dia based on the impedance. Okay. Alright. So impedance relay with directional restraint. So ini dia the first one. Which one? Ya ini This one bukan ini directional restraint by including directional relay in series with an impedance relay. Ini dia, this is the diagram to show impedance relay combined with the directional relay. So trip region kat mana? Without impedance relay, dia akan trip lah. As long the Z located within the ZR kan, dia mesti berada dah. Tapi when you put directional relay, so dia akan ada this curve macam ni lah, circle dia jadi separuh Kenapa? It try to shows that the combination of this relay it only operate at forward direction only. Okay. Kalau tak ada directional relay apa jadi? Dia akan jadi full full circle lah, betul. Dia akan balik macam ni lah. Kan? Dia jadi macam ni. Tapi because of the directional relay, it based on a forward direction, so dia jadi half. Okay? Faham just forward direction. Right. Okay, kalau nak tanya boleh tanya, tak ada masalah Okay, the second one is the modified impedance relay. It back to this diagram, but it's modified the center. Center ni kat tengah the shift ke atas the shift you can see this is the circle. So trip region dia only the forward direction. Okay, application dia kat mana kita boleh guna. Ada some application power system protection dia pakai this impedance relay combine dengan direction relay. Dia ada one dia orang pakai more relay Tapi fahamlah kalau more relay biasanya dia akan shift the center of the circle above the R axis atas lagi. Okay. Tapi still dia operate at the forward direction. Okay, impedance relay. Sekarang ni right, sebab because kat sini kita mungkin you tak berapa clear pasal why it has this zone 1, zone 2, zone 3. So dalam slide ni we explain Okay. Alright. It is common practice to use 3-directional impedance relay per phase with increasing reaches ZR times delay. Thus, there will be 3 potential zone covered by the relay per phase. So ini dia zone 1, zone 2, zone 3. So actually it reflect dengan zone 1, zone 2 and zone 3. Okay. Alright. Okay. So if you relay with directional restraint yang tadi the first one, and second one more relay pun sama, zone 1, zone 2 and zone 3. So R1 is reach 1, reach 2, reach 3. So again port must be located within the dalam range ni dalam this circle half circle ni. Kalau tak dia tak, kalau outside dia tak cooperate Kita tak konsep dia. Okay. So in practice, each directional relay, impedance relay will have 3 protective zones as shown below. So zone 1, zone 2, zone 3. Zone 1, 2, 3 are the protective zone covered by breaker B1, 2. So let's say for B1, 2, zone 1, zone 2 and zone 3. Okay. For example, consider B1, 2 with 3 relay per phase for a previous power system. Zone 1 provide primary protection for line 1, 2. So, kat mana buat line 1, 2? This is the line bus 1 and bus 2. So, this is the transmission line. So, the primary protection. So, basically zone 1 ni dia akan sebut primary protection. Kalau kata primary tu, bila fault dekat P1, okay, ini dulu akan trip. Okay? Alright. Relay is typically set for 80% reach of line 1, 2. Any fault happen between the relay and 80% of the line length will be cleared by this relay. Instantaneous operation. Maksudnya dia detect fault, dia akan terus automatically clear the fault. No delay at all. Okay. Alright. And then we have second zone. Zone 2. Okay, what is the zone 2? Zone 2 basically provide backup protection for line 1, 2 as well as remote backup for line 2, 3 and 2, 4. Okay. So backup for line 1, 2 to 3 and to 4. So maksudnya dia backup. Kalau zone 1 ni tak trip, dia tak sense ada problem, so dia akan relay yang kat sini lah, breaker ni akan turn on, dia akan remove the fault. Okay, so relay is set about 120% reach of line 1, 2 extending beyond bus 2. So maksudnya kat sini, this is only 80% zone 1. Zone 2 ni dia kena tambah lagi another plus 120%. Okay? Tambah So kalau kita ikutkan kat sini ialah kalau line B1 ni 100%. 80% kat sini kan, sini ke sini is 100%. So you can tambah additional 20%. Between 2 and 4. Okay. So jadilah 120%. Right. And dia ada time delay about 0.2 to 0.3 second. So zone 2 ni ada delay pula 0.2 and 0.3 second. Backup protection. And then the last one is zone 3. Okay, what is the zone 3? Zone 3 provide remote backup for neighboring lines. Relay is set 100% reach line. So maksudnya 100% of 1, 2 plus 130% of either 2, 3 or 2, 4, whichever is longer. Is extend beyond bus 3 and bus 4. Typical delay is 1 second. So masuk kat sini. For the bus 3, dia akan cover 100% of line 1 to 2. Okay, and then we have to choose between 2 and 4, 2 and 3, which is the longer. Kalau case ni yang inilah, kalau between 2 to 4 ni, the length of terrestrial line ni is, kata this one is longer than 2 to 4. So we choose this one. Okay. Right? Right. So 120%. Maksudnya it must be more than the you kena extend lagi 20% daripada 100% of line 2 to 3, additional 20%. Okay. Alright. So okay, time delay 1 second 1 second. So itu masuk zone kat sini Right. Tapi what happen kalau fault kat sini? This fault dia tak cover kata apa bus ni akan cover, breaker dia akan cover untuk fault kita. Right, kalau dia masukkan dia akan cover. Alright. Okay, we go to the next slide. In order to determine the 3-pin status of impedance relay, the secondary impedance of relay transformer Z prime must be determined. Secondary. Okay. So cerita sekali, kita in order to determine 3-pin or not, contoh kalau ni, so we need to determine the Z prime, secondary impedance. So this is the equation to determine the secondary impedance. So dia ada banyak equation ni. So at the end, so this is the general equation. Z prime equivalent to Z and CT and CT and VT is the ratio of current transformer, ratio of voltage transformer. So you can see from this V prime secondary voltage, I prime secondary current, V phase voltage. So I phase current, Z is primary impedance, and VT and CT is the CT and VT ratio. Kita akan buat exercise later on, so untuk you faham. Okay, after that, the setting ZR is calculated based on the percentage of reach defined for each zone. The setting impedance of a zone ZR equivalent to R Z line. Okay, so first step, you kena tahu the secondary impedance. Then second step, second you have to know the reach. Kenapa? Because we back to the basic of impedance relay. So we need to know either the Z prime must be located inside the circle, or we can say less than the reach impedance ZR. So this is the step yang you buat lah later on. Okay. First, determine the impedance Z prime using this formula. And second, by using this formula, you determine the ZR. Okay, by comparing Z prime is less than ZR, we can determine that whether the relay trips or not. Okay, impedance relay connection of 3 zone impedance relay with directional restraint are shown below. So this is with relay with directional restraint. Maksudnya the first one. Yang mana yang ini Yang ini, this one. Okay, kita tak discuss about the more relay Kita more discuss on this with directional restraint. Okay, not this one. Right. Okay, relay connection for three-phase zone, three-zone directional impedance. So ini ialah for the three zone, zone 1, zone 2, zone 3. So we put in series kat sini, ya. Okay, konsep dia sama, macam overcurrent relay juga, right? So in order to breaker to tricks, you kena tengok kat sini ada T, so it means that the time delay, kalau zone 2 yang tadi lah, kita refer balik pada this one, okay, zone 2 0.2.2 0.3 second, zone 3 is 1 second. So back to this diagram. So dia ada time delay kat sini, T2, T3. T2 represented the zone 2, T3 represented the zone 3. Okay. So kalau for example, if the Z2 turn on, tapi kalau dia tak times delay tak turn on pun dia tak turn on juga, dia bentuk series, okay. Alright. Okay, example. Table below give positive sequence line impedance as well as CT and VT ratio at B12 for the 345 kV system shown in the previous diagram. Determine the setting ZR1, ZR2 and ZR3. The B12 zone 3 zone directional impedance relay consider only solid three-phase fault. Maximum current for I12, I22 during emergency loading condition is 1500 amps at power factor of 0.95 lagging. Verify that B12 does not trip during this condition. So dia agak panjang sebenarnya, tapi kalau final akan masuk jugalah, dia akan ada tanya juga pasal protection, okay. Alright. Okay, so macam mana nak solve this one, kita balik pada basic. Kita tengok soalan mungkin tak faham apa kau nak start. Okay, back to this circuit, diagram ni, okay. Yang mana ya? Kita ni kita kena tahu Z range, but refer pada this zone, So each zone we need to know the Z1R, Z2R and Z3R. Itu masuk dia dalam question ni, okay. Right. That's why determine the setting ZR1, ZR2 and ZR3 for the B1, 2, 3 zone, Zone yang mana? Zone ni, zone 1, zone 2 and zone 3. Right. Okay. Alright, so this given positive sequence impedance for each line 1 to 2, 2 to 3, 2 to 4 and 1 to 3, and this is the ratio for current transformer and voltage transformer. Okay. So kita start kat mana, Kat sini. So in practice, each directional impedance relay will have 3 voltage zone as shown below. Kita balik pada this circuit. Alright. Okay, so kita sekarang ni we want to determine the ZR1, ZR2 and ZR3. So by using this formula, ingat tak formula mula tadi kita guna, okay, ZR, okay. So this is the R Z line ratio of current transformer over voltage transformer. So R is the reach percentage. Z line is the line given in the question, Okay, the first one yang mana ni, Okay. So R 80% because R1 is 80%. So R1 is 80%. Yeah. Z12 from the question kat atas ni. Ya kan? 8 plus J50. Okay. Right. Ni, And then NCT over NVT. So NCT over VT you boleh determine by this calculation, from the question. Question dia bagi dah. Kan, ratio is 1,500 over 5, 3,000 over 5. So to get the CT over VT ratio, right? So you just divide the CT ratio bagi dan VT dapat lawan over 10. So from here, so 0.1 is 80%. Z12 is from the question, right? Then they have the ratio of CT over VT, 1 over 10. So you have the ZR1 is 4.05. Okay. Maksudnya kat sini kalau balik pada back to the yang ini. Oh no, okay, kita tak ada zone kat sini. Kali ini this one, So ZR1 ni, zone 1 ialah that value lah yang kita kira tadi. Second, kita akan kira ZR2 and third, kita kira ZR3. So now we have ZR1 which is about apa tadi? Tak ingat lah. 4.05 with the angle of 80.9. Okay, ZR1. Okay, how about ZR2? ZR2 again 120% reach of line 1, 2. So kat sini ada 120% Z12 from the 8 plus J50 1 over 10, so you dapat 6.08. And similarly for zone 3, 100% of line 1, 2, 100% of line 1, 2 plus 2 to 3 or 2 to 4, which over is longer. Tapi kita ceritakan kalau back to this circuit, 2 to 3 lah, kan longer kan, betul lah. Ini lagi short shorter than this one. So we choose the impedance of 2 to 3. So from the question, yang mana 2 to 3? Okay, 2 to 3 is about 8 plus J50. So Z13, 8 plus J50, 120%. Okay, so now we have all the reach impedance, ZR1, ZR2 and ZR3. Okay, so basically kita back to the diagram kat sini, we have R1, R2, R3. So now kita nak tahu trip ke tak. What need we to do? We need to determine the fault impedance saja kan. Kat mana? Adakah fault impedance tu berada dekat area mana? Okay. So faham tu dapatkan ZR1, ZR2 and ZR3? Boleh faham? Semua faham ke?
Boleh.
Boleh kan? Simple kan? So I try to back to the circuit ni lah. Diagram. Sebab nak bagi faham sebab kalau cerita straightforward nanti tak faham So kita tahu in order relay to trip, it must be unidirectional. It must be within the circle. Kat sini lah. Kat sini. Dia mesti Z prime ni, impedance must be within the Z reach. Kalau tak, dia tak akan be. Dia akan block. Block ni maksudnya relay tak on lah. So just in this area. Okay. Alright. Okay, sampai sini. Okay, now we need to determine the what we call the impedance fault. Alright. Okay, from the question, given 345 kV, fault current is 1005 amps with power factor 0.95. Again, so kat sini you can determine the impedance, fault impedance. So, of course, ini ialah line voltage. You tak boleh pakai direct straightforward. You kena tukar kepada phase voltage by divided by square root of 3. So, jangan salah. Saya tengok calculation some of you ni, you straightforward pakai line voltage. Salah calculation dalam bentuk phase. Right, so divide by square root of 3, you dapat 199 over 0.2, angle kosong lah voltage. Currents 1500 with the lagging power factor. This is the value of current. So you can determine the Z prime. So we phase over Z phase. Tapi because this is not the impedance. This is what you call secondary impedance of the transformer lah kan. So you have to add the CT over NVT. Kalau ikutkan logiknya, you have to back to this equation. This one. Yang mana? Ini Okay. Okay, ini dia untuk determine the secondary impedance atau fault impedance. So we have substitute all the components. Then you have 13.28, 13.28. Angle minus angle tak penting lah, yang penting the magnitude. So see the Z prime magnitude is greater than ZR1, ZR2 and ZR3. Betul tak? 13.28. Kalau you look at here, ZR3 11, 6. This one 4, betul lah? Correct. So maksudnya because the Z prime is 13 which is greater from those rich impedance. ZR1, ZR2, ZR3. So relay tak trip for this fault. Kita akan trip. Relay no so no relay will trip ayat dia. Okay. So cerita ni kalau nak trip what we need to do, we need to determine Z must be less from all these reach setting lah. Kalau 11 it must be 10. Kalau within the region lah, within the reach zone. Pada 13 kalau kita balik pada basic dia berada di atas dia dalam block region dia letak operate won't operate. Okay, right, so that's for impedance relay. Okay, so I hope you faham about 80%, 120%, 100% plus 120% based on this diagram. Okay. Right. The next one is about differential relay. Sebenarnya kalau ikutkan syllabus semester ni, this is the last topic kita akan discuss. Okay. Maksudnya the protection. Alright. Okay. So the last one is about the differential relay. Right. So what is the differential relay? So nama pun differential. Differential maksudnya different perbezaan in term of current or voltage. Dia ada voltage current differential relay. When kata current differential relay means that the difference between the currents relay to cooperate based on the current difference between among this current current 1 and current 2 contohnya. So relay cooperate. Kalau voltage differential relay based on the voltage. Right, but we are more focused on the current. Okay, commonly used to protect generator, bus, power transformer and transmission line. So the differential relay ni konsep dia, kalau you tadi sebelum ni you belajar tentang overcurrent relay, directional relay, apa lagi impedance relay. These relay are designed to protect transmission lines. Specifically dia akan protect transmission line. However, to protect the equipment, we are using this type of relay known as a differential relay. Okay, right. Commonly used to protect generators, buses, power transformer and transmission line. Yes, we can also use to protect transmission line, but the common application for usually to protect the generators, bus and power transformer atau equipment in the power system network. Okay, this relay operate based on the difference in current entering and leaving the component. So, saya kata tadi kan based on the different current. So, in this case, different in term of current entering, current yang masuk dan current yang keluar from a component. So, maksudnya kalau you nak protect generator, current yang goes into the generator and outside from generator. If there is a difference, okay, dia akan sense the difference. Dan dia akan decide sama ada itu fault atau tidak. Okay, the entering current is noted as input current I prime, I1 prime, while the leaving current is noted as output current I2 prime. The condition for differential relay to trip, okay, this is the condition. Okay, current goes in I1 prime minus I2 prime, not equivalent to 0, ataupun dia relay will trip. Maksudnya kalau tak sama kosong, maksudnya there's a difference between I1 prime and I2 prime. Betul Betul lah. So maksudnya dia akan ada fault kat situ. So relay tu boleh sense the fault. Oh, ini fault because current entering and current leaving tu tak sama difference. There's a different in terms of magnitude. So relay akan trip. However, when I1 prime and I2 prime, maksudnya current yang masuk dan current keluar tu dia lebih kurang sama kosong. Tak ada difference. So relay will not trip. So these are the concept of differential relay. Faham Maksudnya current yang masuk go in and go out tu mesti ada beza barulah kita tahu oh ada fault. Ada fault current lah. Kalau tak ada, maksudnya in and out sama so relay will not trip. Okay? Alright. So figure below illustrate the basic method of differential relaying for generator protections. So biasanya you akan ada dua macam ni lah. We try to protect the stator winding. Kita tadi equipment it's not the transmission line. The breaker whatever tak ada it based on the equipment protection. So we have basically connection ni macam ni. Dia ada dua CT ratio connected. Satu dekat sini and the other one dekat the other side. Okay. Alright. So then we have restraining coils, relay operating coil, konsep sama saja. But cerita kat sini, whenever there's a difference in terms of I1 prime minus I2 prime, it will operate the relay operating coil. Dia akan trip. Dia akan trip the circuit breaker kat sini. Konsep dia. Kalau tak ada difference, this operating coil dia tak akan on. Dia tak akan turn on dan breaker dia tak akan open. Itu cerita. Right? Dia ada operation yang berlaku. Okay. When the relay in one phase operates, all three phases of the main circuit breaker will open, as well the metal, neutral and feed breakers. Okay. Maksudnya kalau ada fault lah, operates, breaker open. to protect the generator. The 3P of differential relay is as follows. When no fault happen in the generator or stator windings, the current in the relay operating coil is zero. Maksudnya I1 prime minus I2 prime is zero. No fault. Okay. Maksud kat sini, no fault. Relay to operate, no fault. Zero. Okay, relay does not operate. When the fault happen in the generator windings, the current of relay operating is not zero. Maksudnya when I1 prime minus I2 prime is not equivalent to zero, so relay operates. It's a simple concept, yeah. Okay. Alright. Okay. An electromechanical differential relay called a balance beam relay is shown below. Jadi kalau ikutkan detail structure for differential relay dia macam ni lah. So dia ada macam ni. Dia ada satu ialah kita panggil center type restraining coil. Cerita inilah relay yang akan sense the I1 prime and I2 prime. Dia macam coil. Kalau ini okay. Then when the different exist between these two current, kita katakan atau mismatch lah, mismatch perbezaan. Dia akan turn on the operating coil. When turn on operating coil, what is FL? FL is the force left, force right. Whenever force right is greater than force left, dia akan trip. Maksudnya dia akan move downward. Dia akan push the contact to turn on. Ini maksudnya structures of the differential relay. Okay. Kalau tak dia, kalau force right ni less than force left, dia tak akan downward, dia akan turun. Maksudnya contact to open. Kalau contact close, whenever ini turn on. Macam mana ini nak turn on? This current dia ada mismatch between the I1 prime and I2 prime. Barulah turn on. Okay. Alright. Okay, the relay contact close if downward force on the right side exceed the downward force on the left side. Ini maksud dia. Dia close kalau left dia right this one right is greater than force at the left side. Okay. The electromagnetic force on the right Fr is given by this formula, right? And similarly for the electromagnetic force on the left, restraining coil is proportional to this formula. And the relay will trip if Fr is greater than Fl. Tapi macam mana nak jadikan Fr is greater than Fl? Ini kena turn on lah. Macam ni turn on? Kalau dia ada mismatch between the I1 prime and I2 prime. Barulah coil dia akan turn on. Okay. Okay, so dah ada equation kat situ. Tapi the important is the K. What is the K? K is the ratio between these two coil. Satu kita panggil center tap restraining coil. Dia ada center tapping tengah-tengah ni, ada tapping. Kalau you buy transformer, dia ada tapping kat sini. And then the other one is the operating coil, the ratio between these two coil. Kita panggil K, constant coefficient. Right? So if we do the derivation all the way, so you akan dapatlah all this general formula in order to the condition for relay to trip. Okay? I1 prime over I2 prime must be greater than 2 plus K minus 2 minus K. Trip region. Ataupun we can put in this way or this way. Ni guna untuk apa? This one biasanya kita guna untuk kalau you ada graph ke apa, okay. Sebenarnya kalau you tengok betul-betul, if you study this is the slope ataupun nak katakan slope lah. Satu kecerunan. So the previous inequalities are plotted to obtain the block and trip regions of the differential relay. So kalau differential relay dia ada juga dia punya diagram to show the block and trip region. Macam tadilah macam impedance relay kan. So kalau untuk differential relay, so it has this diagram. So satu kalau in between ni the block region, dia tak akan turn on. Maksudnya the mismatch between the current exists in this block region, so dia tak akan turn on. However, when the mismatch between the currents exists in the upper bond or lower bond, maksudnya dia berada minimum kat sini atau dekat sini, not in this block region, relay will trip. Okay. This one for K equivalent to 0.1. K can be varied. K boleh berubah, it can be varied. Right. Sebab K is the ratio between the two turn ratio of the coils kan. So that's why I cakap K can be varies, dia boleh ubah. So for this case is K0.1. Right. Okay. So for upper bond, percentage of mismatch between the I1 prime and I2 prime in this formula. Ini contoh kalau based on this diagram, when K equal to 0.1, if we do the calculation, we dapatlah for upper bond is 11%, lower bond is 9.5. So maksudnya apa? So hence it can understood that the relay will block for up to 11% mismatch between I1 prime and I2 prime, down to 9.5% mismatch between I1 prime and I2 prime. Maksud kat sini gini lah, nak faham if the mismatch, sebab ingat differential relay dia the mismatch, perbezaan di antara I1 prime dengan I2 prime. If the mismatch kata locator exist dekat sini, tak boleh, dia takkan turn on. Dia mesti berada atas ni ataupun kat bawah ni. So itu maksudnya 11% and 9 to 5%. So maksud kat sini lah 11% and dan kat bawah pula lower bond is 9.5%. Okay, in other words, the relay will trip if the mismatch between the current is either below 9.5%, below bawah okay, semua dia trip lah kat sini or else is 11%. 11% ni atas upper bond 11%. Tak salah 30%, 20%, as long dia minimum is 11% for the upper bond, the minimum is 9%. Okay. Alright. 9.5%, sorry. Okay. Differential relay. Note that K is increased, the block region become larger. Example, the relay become less sensitive. So, the ratio between the coils, K tadi, must be controlled. Tak boleh selalu besar. Nanti dia less sensitive. Alright. Advantage of differential relay are provide primary zone protection without backup. Connection with protection in adjacent zone is eliminated. Permit high-speed tripping. Precise setting are unnecessary. The tip to calculate fault current and voltage is avoided. So, cerita sekarang senang because they're based on the mismatch of the current. Current yang masuk dan current yang keluar. Current goes in and current goes out based on this diagram. Kalau tengok betul, current sini masuk, dia akan sense by CT, dia akan produce the I1 prime. Untuk side ni pula I2. Sama juga, dia akan step down kepada I2 prime. Okay, itu maksud dia. No need to determine calculate the fault voltage or current. Okay, sampai sini. Alright. Sekali lagi differential relay for bus potential is illustrated by the following. Ini untuk yang tadi untuk what we call as a protection for transformers. Okay. Juga we can use the differential relay to protect bus system. Konsep yang sama. Contohnya this is our bus. We try to protect this bus. So connection dia different sikit lah because dia ada parallel feeder kat sini. So CT1, CT2. This is the kita current keluar daripada bus ni. So we have either CT here. So what happen is the total of I1, I2 prime minus the I3 kalau in order to kalau no fault condition equivalent to 0 lah. Tapi when there is a fault, I1 plus I2 prime minus I3 prime not equivalent to 0. So dia akan sense the fault. Konsep yang sama, cuma different in terms of number of CT yang connected with the bus. Okay. Alright. Okay, ini dalam parallel ada juga bus yang pakai satu feeder. So kalau satu untuk dua je lah, satu, dua. Ini contoh untuk dua feeder. Okay. In practice, 3 different relay are required for each phases. Okay. Alright. Operation of any relay would cause all the 3-phase circuit breakers connected to open to the bus to open, thereby sorting the 3-phase bus from service. When there is no fault happen at the bus, the current in the relay operation is quite zero. Saya cakap tadi, relay doesn't operate. Whenever fault happen at the bus, relay operate. Whenever this calculation not equivalent to 0. Konsep yang sama untuk transformer or to protect the system. Okay. Differential relay from transformer protection. Tadi generator ke? Tadi generator. So the first one is generator. Then we go to the potential of the bus. Then the next one is the transformer. Okay, this is transformer, right? Kenapa the first one is a generator? Because you tengok betul dia nak protect winding kan? Itulah winding So this is not, this is the generator. Okay, how about the transformer? Okay. The potential of method for use for power transformer depend on the transformer MVA rating. Fuels are often used to protect transformer with small MVA ratings, whereas differential relays are commonly used to protect transformer with rating larger than 10 MVA. So dia not practical for a small size of transformer, but the largest size of transformer, larger than 10 MVA, besar tu, 10 MVA. Okay, so this is the circuit configuration to protect the transformer. Okay, differential okay, single phase, two winding transformer. This is single phase. Kalau three phase lagi complicated sebenarnya. Single phase, straightforward. This is primary and this is secondary. So we locate our CT, CT1, CT2. So konsep sama. Difference between this I1 prime and I2 prime, coil turn on. Then they will protect the windings. Okay. Okay, denoting the turn ratio of CT1 and secondary CT2 as follows. Right, so we do all this calculation, derivation. Okay, so you have this value of I1 prime. So this is I1 prime. Okay, when no fault happens, the primary secondary current of two winding transformers are related to I2. When N2, N2 primary, N1 and N2 are the primary secondary winding of two winding transformers. Substitute into this equation, you will have this I1 prime. Kat sini pakai I prime saja. Okay. So to prevent the relay from tripping at no fault, the differential relay current I prime must be zero as no fault. Kalau you faham yang ni, you faham lah benda yang sama. Konsep sebab dia pakai relay yang sama, konsep yang sama. Okay. Right. So whenever fault, again, dot zero, relay, okay, this is the trip condition, right? Okay, also the value K equation can be selected to count the size of the block region of differential relay. Okay, hence the transformer potential use differential relay. Okay, so we can use this condition, right? Kenapa ada K? Because you can faham, transformer ni dia ada based on turn ratio, Dia tak specific on any one value, So dia boleh adjust, Turn ratio, that's why you guna ada turn ratio, Alright. Example. Okay, ada example kat sini. Alright. Kita ada sikit example. Dah tak banyak dah pun. Kita tengok pada example question. Kalau tak buat example, kita tak faham. Okay, tengok pada example this example. A single phase two winding 10 MVA 18 to 20 kV transformer has differential relay protection with two current transformers at primary and secondary sides. Determine the current in two winding transformers and the CT at rated condition. Hence, select the suitable CT ratio based on the following table. So, very interesting question kat sini. Okay, what we have here? We have single phase transformer, two winding, 10 MVA. Okay, primary voltage is 80, secondary voltage is 20 kV. Use differential relay protection, two current transformers at primary and secondary side. So maksudnya dia base pada yang ini, inilah two CPs. Dia protect primary and protect secondary. Okay. Determine the current in two winding transformers, current, right, and CT at rated condition. So cerita soalan ni, select the suitable CT ratio based on the following table. Maksudnya, for this condition, which the suitable CT ratio. Yang mana sesuai? Right? So, ada banyak CT ratio kat sini. Ingat, CT ratio ni biasanya dia akan step down to 5 ampere. Taklah exactly 5, tapi the ratio, the standard, 550 to 5. Maksudnya, apa maksud 50 to 5? Maksudnya, this is primary. 50 amps, dia akan step down to 5 amp. Kalau break kat sini, mana? This is the 50, dia akan step, 50, dia akan step down pada 5 ampere. 50, 5 ampere. So that is the, the CT ratio. Alright. So sekarang soalan ni ialah senang, soalan simple. Determine the suitable CT ratio. Dalam banyak-banyak ni, which is the suitable CT ratio for this condition, for this transformer. Okay. rated primary and secondary current for two wire transformer. So cerita sekarang, the first step you need to determine the rated current for the primary and secondary current. Yang mana kalau you balik pada soalan ni, this is the primary and this is secondary voltage. Tapi you kena cari current because CT ratio is the current bukan voltage. So from this formula, semua tahu formula ni, I1 primary, S divided by the V1, S is the apparent power, 10 MVA divided by 80K, voltage of V1, primary voltage, you dapat 125 ampere. Okay, for the secondary side, S over V2, 10 MVA divided by the 20K. Where's the 20? It's come from this one. 80 ini. Okay, right? So you dapat 500 ampere. So based on this current rating, so we can choose the suitable CT ratio. Okay, CT ratio must be greater than rated current. Maksudnya kalau the first one is 125. So kalau 125 back to this table, dekat mana letaknya 125? So they start from 50, 100, 150. So the close is the 150 and 5. That's why kat sini pick the 150 and 5. Then tab setting. Ini tab setting the ratio. Ini current ratio. Ini is current ratio. Current ratio. Okay. I2 is 500 ampere. So 500 ampere, the close one is this one. Okay. Kalau you ambil 500, dia dah exactly same values, so tak sesuai. So we choose the highest the higher one from 500 is 605. So we choose 605 for the ratio, current ratio, CT ratios. Okay, right. So CT ratio is 605. So this is the solution lah. Okay. So then the next one, next one dia cari mismatch. Okay. If we do the calculation to determine the I1 prime and I2 prime, ini kat mana? Ini I1 prime, I2 prime ni basically the current that flow inside the current transformer. Yang mana kalau you balik pada asal kayak ini yang tadi you kira yang secondary and primary. Tapi yang ini this one and this one. Based on the CT ratio that we choose from the table, so we can get the value of I1 prime is 125 divided by 150 over 5. Kenapa? Because we choose 150 over 5. Kat sini, this is 100 over 5. This is 100 over 5. So dapatlah the current is, for I1 prime is 4.167 and the other one is 4.167 ampere. Sama patut sama lah. Kalau dia ada mismatch, dia akan trip lah relay tu kan. Okay. Alright. Faham Okay, common problem in differential transformer protection. A common problem in differential transformer protection is the mismatch of the relay current I1 prime and I2 prime that occurs when standard CT ratio are used. Contoh yang tadi bila kita choose the suitable CT ratio, ini betul kan? CT ratio, what happen is kalau case ni you dapat nilai yang sama, there's no mismatch between the I1 prime and I2 prime. You fahamkan konsep of differential relay, dia based pada mismatch between the currents. Okay, maksudnya kat sini kalau ada mismatch, ini akan turn on, dia akan trade, dia akan protect. So issue dia sekarang ni, from the first calculation kita buat tadi, what happen is dia tak ada mismatch, dia sama kan. Maksudnya kita choose the correct CT ratio. Sometimes dia ada different in term of contoh kita tak tahu, kita pergi one by one lah. A common problem in differential transformer is a mismatch of relay current I1 prime and I2 prime that occurs where standard CT ratio are used. If the primary winding is the previous example has 138 kV instead of 80 kV ratings, then the rated primary current, contoh kalau soalan tadi inilah 80 kV, so bila you kira-kira you dapat nilai yang sama. So no problem because dia tak ada mismatch, dia tak ada different. However, let's say if not 80 kV but 138 kV, so what happen? If you use 100 kV, you kira the currents then 72.46, and then kalau you select 100 over 5 because the value of 72.16 you refer to the table. Yang inilah kan mesti you pilih yang ni because dia ratio is 100/5, dia greater than 76. Okay, what happen is bila you kira the I1 prime, you dapat 3.62. Kan? Tapi kalau you look back, kalau I2 prime is 4.176, dia dah ada mismatch kat situ. Dia dah tak sama. Nanti what happen is kalau ada mismatch, apa akan jadi you rasa? Apa akan jadi? Kalau ada mismatch I1 prime dan I2 prime, apa akan jadi? Siapa nak jawab soalan ni? Apa akan jadi? Ramai-ramai ni? Nak test sikit. What will happen? Kalau mismatch, dia bukan fault tapi mismatch of the city ratio sebenarnya. Menyebabkan kat calculation for I1 prime dia ada mismatch, ada different. Tak sama between this current. Apa akan jadi? What will happen? Trick lah, very good. Trick lah kan. Itu isu dia, itu common problem dia. Dia akan trick lah sebab dia cuma sense the mismatch, the difference between the current. So what we need to do? Hence the mismatch. Kat sini pun jawapannya kan. Okay. So about 50%. Right? Solution to this problem can be solved through auxiliary city. Dia ada, kita pakai city circuit. Auxiliary lah. Additional city. Connected to the standard city. Use tap setting on the relay. So kita juga boleh pakai dua cara. Satu tap setting. Tap setting apa tap setting? Tap setting dia ada tapping kita boleh step up the voltage or step down the voltage. Sebab contoh case ni 138. So kita kena step down kepada 80 contoh in order to have no mismatch at all kita pakai step setting, step down kan dia kepada 80 kV. Itu antara solution But we need to differentiate between fault current and the normal operating current. Okay? Or otherwise we can use auxiliary circuit city boleh juga. Simple method kita boleh pakai tap setting on the relays. Okay? Alright, kat sini ada lagi example untuk tap setting. Dah tak banyak pun sikit lagi kita habiskan sikit lepas setengah pun. Okay. Alright. Okay, sikit lagi Okay, a single phase 30 MVA, 240 kV, 65 kV. Dia step down by 65 from 240 kV. Two winding transformer is protected by differential relay. Okay, kalau kata differential relay, alright. So you imagine dalam kepala you, okay, no mismatch. Kalau tak nanti dia akan errors. CT akan current relay akan operate at start the fault current. Okay. Assume that available relay tap settings. This is tap setting. Giving the tap ratio, this one. Okay. Relay tap. Okay. Determine the current in the transformer and in the CT rated condition. Satu cari current ni. Okay. Select the CT ratios and relay tap setting. Hence calculate the mismatch in the relay current. Okay. Okay, soalan dia ada tiga kat sini. Determine the current in the transformer in the CT at rated condition. Okay, cari CT ratios and the tap settings. Hence calculate the mismatch in the relay current. Okay, then later on cari mismatch. Kita go one by one. Okay, rated. Okay, kita back to the question dulu. Okay, 30 MVA, 240, 65. So, you kena cari primary and secondary current. Yang untuk apa? Back pada soalan ni lah. Okay. You have to determine the primary and secondary current. Later on, you can determine the I1 prime and I2 prime. So this is the primary and secondary current for transformers. These are the primary current for CT. Jangan salah ada different kat sini. This I1 prime is the CTs. Current. Sekarang yang perlu ikut CT pada step down this I1 prime. Sorry, after CT step down the I1, dia akan jadi I1 prime. After it step down the I2, dia akan jadi I2 prime. Okay, itu maksud dia. Okay, alright. Right, this one Okay, so the primary current S over V1 macam sama, konsep sama for I2. So we have 1 to 5 ampere for 61.5 54 ampere for I1 and I2. Right. Since I1 is 1 to 5 ampere, choose one macam tadi lah. You dapat 1 to 5. Okay. So we choose 150 over 5, the current ratio, say this one. Okay. Second one, we choose 500 over 5 because 500 is greater than 461. Yeah. Ini dia 500 over 5, this one. Yeah. Okay, you have this one for CT1 and CT2. So next apa yang kena buat, you kena dapatkan nilai I1 prime and I2 prime. Konsep yang sama. You dapat the value of CT. So now we have the value of I1 prime is 4.167. I2 prime based on the selected CT ratio tadi, you dapat 4.615. Okay. Relay type setting can be determined from this equation. So this is the ratio between I2 prime and I prime, which is equivalent to 1.11. Hence, the cross-set type ratio is 1.110. So choose relay type setting 111. Sebenarnya gini, 1.11 ni dia back to the question kat sini. Okay. Mana dia? Yang paling hampir lah kan. So the ratio between this primary and secondary current for the current, ini current transformer is 1.11. So back to this question okay, yang paling hampir ialah this one 1.10 tu maksud dia. Yang ini that's why kat sini dia kata cross set ratio is 1.1. So the chosen related set is T1 prime over T2 prime is 5 ratio with the 5.5. Yang mana yang ini ini is method setting. Ini method setting kat sini. Okay, ini ialah ratio between the current of I1 prime and I2 prime over I1 prime. So you dapat yang ini kan, this one. Kalau you back to this question, maksudnya nombor 1, nombor 2, nombor 1, nombor 2. So maksudnya dia ambil yang inilah 5 ratio with 5.5. Kenapa ambil yang ini? Because sebenarnya yang ini, this group ni dia relate dengan this one. Maksudnya kalau you pakai 5.5, you kena pakai ratio 1. If you use 5 ratio with 5.5, you have to select this one. So dalam soalan ni, after they do the calculation, you dapatlah the close value of this 1.10, which is refer to this setting 5 ratio 5.5. So inilah dia. Okay. Alright. And then the percentage of mismatch given by formula ni dalam tak ada tak perasan ni. Saya tak tahu. Ada tak apa, you can use straightforward daripada tak ada dalam calculation. Takkan you boleh pakai straightforward lah. Oh, ini penyakit tak apa. Then the percentage of mismatch given by this formula, tak apalah. Kan, sudah dapatlah kat sini T2 is 5.5. Sebenarnya T2 5.5 ni dia refer pada sini. This is T1, this is T1 prime and this is T2 prime. Okay, so 5.5 is to T2 prime. Ikut balik pada soalan dia. Okay, ni ini dia. Alright, so that's why dalam this equation is 5.5. 5. So you dapat mismatch is 0.683%. This is good mismatch since transformer differential relay typically have their block region adjusted between 20 to 80%. So 0.63 mismatch give an empty safety margin. Okay, sebenarnya kalau tengokkan mismatch dia tak besar, 0. something. Maksudnya the current kat sini. Okay, kita isu tadi kalau tak pakai tab setting, what happen, nanti dia ada mismatch. After we use the tab setting, we choose the correct tab setting, so dia akan dapat macam ni lah. Betul, in term of mismatch sangat small 0.63%, which is still lagi orang kata acceptable. Okay, so itu maksud dia untuk this example from this common practical problem. Right. And the next one is three-phase transformer protection with differential relay. Banyak ada 3 slide lagi. Okay. The previous example is about single phase. Now 3 phase. Transformer you tahu kan, transformer dia ada connection single phase dan 3 phase. Dan star delta itu there's a connection for three-phase transformer. Okay, figure ni, this figure figure ni illustrate differential protection of three-phase Y delta two winding transformer. So this is the Y delta. Okay, this is Y and this is delta connection. Okay, not Y delta transformer produce 30-degree phase shift in the line current. Memang betul Y to delta, if you study, there's a phase shift between the currents about 30 degrees. So the CT must be connected to compensate the 30 degrees phase shift such that the CT secondary current as seen by relay are in phase. Isu dia gini, kalau Y delta connection for three phase ni, basically dia akan ada phase shift. So cerita nanti untuk current transformer dia kena has a different connection with the transformer. Dalam ni pun dia ada explain kat sini. In order to make all the current are in phase, the correct phase angle relationship is obtained by connecting CTs on the Y side of the transformer in delta and CT on delta in Y. Maksudnya gini lah, sebab dia ada phase shift, so connection of CT, ingat three phase three phase ni connection dia adalah bentuk star dan delta, dia tak straightforward, different dengan single phase. So for this case, to protect the transformer, three phase transformer, connection of CT, let's say for star connection, dia connected in delta connection, CT is connected in star. Star, dia terbalik saja. In order to do the correction of for the 30-degree phase shift. Itu maksud dia. Okay? Right. So this is the end of the slide. Sampai habis untuk chapter protection system. Okay. Any question nak tanya? Saya rasa cover dah everything on protection system. Okay, boleh faham ke protection? Yes, banyak you kena baca jugalah, you kena tahu. Tapi if you know the concept of protection is for each type of relay, I think okay. I think you boleh, you baca tu you faham lah, kan? You kena faham yang tu lah. Okay. Semua kat sini ada soalan? Kita dah 4:40. Any question nak tanya? Alright.
Setakat yang tak ada, Sir.
Tak ada my student semua tak ada. Bagus. Kalau tak ada, okay. I nak tanya, siapa nama, alamak saya lupa. I forgot the name. Apa nama? Ini siapa ni? Kimiko Boboy ni. Siapa ni? Siapa?
Saya.
Siapa nama you?
Kamiko Boboy.
Itu memang nama you
Ya.
Oh, okay. I ingat nama samaran kampus sebab I tak apa. Okay. You orang Sabah ke? Sarawak ke mana?
Saya Sarawak.
Oh, okay. So, I tak ingat nama ni macam nama samaran kan. Because, I tak check. Macam ni. Because dalam test pun nama ni, saya kata, ini nama ni. Yang lain rasa tak ada masalah. Okay, tak apa. Alright, semua okay semua ceritanya you kena faham lah. You kena faham you punya apa yang you kena buat lah. Untuk Power 1 ni you kena banyak buat exercise. Later on kita akan cuba buat example question. Sebab kita dah week, sekarang ni week berapa dah? In the week of 12 ke 11
11.
11 kan? So week 11 maksudnya tak lama lah. Kita cuma ada 13 to 14 week Mungkin dalam week 14, week 13 ada second test After that you akan ambil break sebelum you final exam. Okay. Alright, so mungkin after this kita akan cuba buat exercise question Okay, I think that's all for today. Itu saja kan? Thank you very much. See you next week insyaAllah. Okay?
Thank you.
Alright, take care. Jaga diri baik. Alright.